Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is equations of straight lines and complex numbers. An important advice: be compassionate. You can find the link of the math website in the description where you can find the soft copy of this lecture. Gradient of straight lines. This is the gradient formula in terms of angle theta. M is equal to tan theta. What if we need equation of this line which passes through origin and makes pi by 4 radian angles from real axis? So the gradient of this line according to this formula will be 1. And this is the equation of this line. Y is equal to x. Equations of straight lines. Example number 1. This argument is given. First write this argument in standard form. Standard form means this sign must be negative and this number must be inside the bracket. So this means we have to sketch a straight line from 2i, from negative 2i of angle pi by 4. So this is the straight line. This is the locus of z of this argument. So in order to find equation of this line, we need to use y is equal to mx plus c, and then m is tan theta, which is tan pi by 4. And c is negative 2, just negative 2, not negative 2i. Tan pi by 4 is 1, so the equation is x minus 2. This is the way to find equation of straight lines in complex numbers. See, gradient is 1 according to this formula. And here is the equation of this line. Make sure you take minus 2. See, the value of c is minus 2, not minus 2i. We have to find equation of this line. So the locus of z is this line, because argument of z means argument of z from origin. So argument of z from origin is pi by 4. So we need equation of this line. Since this angle is pi by 4, therefore gradient of this line is 1 according to this formula of gradient. Hence the equation of this line is y is equal to x. Past paper question, June 2013, paper 31. In an Argand diagram, the loci intersect at P. Express the complex number represented by P in this form, giving the exact value of theta and the value of r correct to 3 significant figures. Let's understand how to sketch these two loci. These two. Well, this means perpendicular bisector. The locus of z is perpendicular bisector of 3 and 3i. Here is the perpendicular bisector. Of these two complex numbers, 3 and 3i. And this means argument of z from positive 2i, and angle is pi by 6. So this is positive 2i and this is pi by 6. So this is the locus of z. And this point is P. This line is here and this locus is here. Now for P, we must have equations of these two lines. Since this line has gradient 1 and this line passes through origin, therefore the equation of this line must be y is equal to x. And the equation of this line must be tan pi by 6 plus 2. Tan pi by 6 x. So 1 upon root 3x plus 2. Now by solving these two equations simultaneously, we can get the coordinates of P. Here is the fair solution. This is the equation of this line, and y is equal to x is the equation of this line. For P, solve these two equations simultaneously. So by solving these two equations simultaneously, we have got the values of x and y. Now we need to substitute these values into this equation. So this is the xy form of P. Now we need modulus of this complex number. The modulus of this complex number is 6.6921 and its argument is pi by 4. To express P into this form, we just need to substitute r here and theta here. R is this and theta is this. This is the 3 significant value of r and this is the exact value of theta. Hence, this is the required form of P in RE I theta form. You can check this solution again.